spawn or not spawn particles when it enters the event. So as I said, it's a one-off assignment, and the only way you can actually change the assignment is by changing the random seed down here. And obviously that will change the random assignment to a different set of particles, but again that assignment will not change on multiple collisions. Next we have the offspring number spinner, and this parameter actually defines the number of particles that can be spawned by each particle as it collides. This value can be altered by changing the parameter spinner here. The next option we have is variation, and this value defines a variation away from the amount defined in the offspring number value. It's a random percentage that can be positive or negative per spawn. For instance, with an offspring value of 10 and a variation value of 100%, on one spawn the variation could be plus 20%, or 2 particles, giving you 12 spawn particles. On the next collision the variation could be minus 60%, or minus 6 particles, for a total of 4 particles on that particular spawn. The next option we have is the sync by flyout, which we've seen in many other operators in our series. And the offspring and variation parameters can be animated over time, and that's where this actually is needed for. This flyout can be used to define what time reference is used to apply that animation to your particles. I won't actually go into any detail on this, as we've covered this over and over and over in other DVDs in this series. But basically you've got absolute time, so it syncs up with the exact frame that you were on at the time. It could sync up with the particle age, or it can actually sync up with the event duration. So you've got the usual 3 options there. The next option we have is reset particle age, and this checkbox allows you to choose whether your spawn particles will actually inherit the age of their parent when they're spawned, or when it's ticked, if they should start with an age of 0. This option obviously is important when later in your flow you want to test your parent or your spawn particles age in some way. So obviously with this unticked, your spawn particles will inherit the age of their parent and effectively will carry on aging at the same rate as the parent. And when you obviously have this ticked, the ages are set to 0 on the point that they're actually spawned. So effectively they're birthed on that frame, as it were. So that's it for, as it were, the amount group. Let's now move on to the speed group. What actually happens with our particles when they actually collide with the surface here. The first 2 flyouts in this group allow us to choose what happens when we actually collide. Here you can see we've got an option for the parent. Will it actually bounce or continue when it actually strikes the collision surface? Then we have a choice for the offspring, the spawn particles. What happens with those? Do they bounce off the surface, or do they continue? So you can see you've got the 2 options there. And if you're not familiar with these 2 options, as I said, you should actually go and view our chapter on the deflectors and the collision test. Then we have a choice of the speed that our actual spawn particles have. You've got 2 options here. You can see the default is an inherited speed, but we have also another option, which is to actually define the speed in world units. So you can see here we've got a speed of 100. We can actually set that to that implicitly. Sorry, explicitly I should say. Or you can inherit the speed of the parent particle, and that's generally the most useful option. You can see here I've actually used an inheritance of 241%. So in other words, the spawn particles inherit the speed and direction of the parent particle, but as you can see there's a multiplier of 2.4 on their actual speed. Then we have a variation value, which is then applied to this inherited value, or indeed to the actual setting here, which is in units. You can choose whether you've got variation on the unit speed or actually on the inherited speed, and you can see you've got a variation here of 0 all the way up to 100%, so you can choose what variation you have there. And then you've got divergence, and divergence obviously allows you to set up a divergence away from the speed of the parent particle. So if we actually tick up here, you can see it's actually going to use the direction vector of the actual parent particle and use the speed value here. And here we inherit the speed. You've got those 2 options, but this particular parameter here actually allows you to define which direction the particles are going to go in. Do you want them to follow their parent exactly, or do you want them to diverge from that path slightly? And obviously you've got a divergence value all the way down from 0 up to 180 degrees. So as you can see, you can actually go in the opposite direction if you need to. So there we go. We've defined how many, we've defined how fast